Hello friends, today we'll be seeing about intermediate code generation. Intermediate code generation is one of the phases of the compiler. This phase helps the compiler to convert the source code written in some high-level programming language like C or C++ or Java into an intermediate code that is helpful for the compiler to convert it into the target code. So, three address code is one of the formats of intermediate code, and three address code is one in which there will be a maximum of only three addresses. There can be less than three addresses, two addresses, or one address can be there, but it cannot exceed three addresses. So, in that format, the source code will be converted into. So, we are taking a translation of a particular construct a or B and not C. So in this construct, if we see, we are having three operators involved. One is OR, the other one is AND, and the other one is NOT. Among these three, we are having highest precedence for NOT operator. So NOT part of the expression will be evaluated first. So NOT C will be evaluated first. In order to hold this temporary computation, we need to have a temporary variable that can store the computation result. So here we are using t1 as a temporary variable that can hold the evaluation not C. And then we are going into the evaluation of the next part wherein we have OR and. Among these two, AND has the highest precedence, and hence that part of that expression will be evaluated next. So we are having B and not C. Not C is already computed into the temporary variable T1, so it will be B and T1. So this part of the computation is now stored in another temporary variable T2, and then finally we have only one operator, that is the OR, which needs to be evaluated. So it is A or B and not C. Thus B and not C is available in the temporary variable T2, and hence A or T2 will be assigned to T3, another temporary variable. Here it is not assigned, this expression is not assigned anywhere, so we are holding it in a temporary variable. So this is the translation of that code A or B and not C into the three address sequence. Now we will take another example, another construct. Now in this construct we have if construct. There it is said if A less than B, then 1, else 0. This is the construct we are having. In this case, how we will convert that into three address code, that is what we are going to see. So there is a condition A less than B involved here. So if there is a condition, there will be a true part and there will be a false part, because the condition can evaluate to true or it can evaluate to false. So what we need to do, if it evaluates to true, that also we need to handle, and if it evaluates to false, what we need to do, that also we need to handle. So this 100 is the quadruple number we are writing. So this refers to the three address code, and what we are writing is if A less than B, go to, we are adding one go to, so that we can say if it is true where the flow of control should pass to. So we are writing if A less than B, go to which quadruple. So here the quadruple number is given as 103. So this is true. If the condition is true, if A less than B is true, it will be going to 103. Okay, so if it is false, if A less than B is false, where will the control go to? It will go to 101. So if it is 101, that is a false part, what we need to do, according to the construct given, if A less than B, then 1, else 0. So the else part is the false part. So we have to assign 0. So we are taking a temporary variable t and in 101, and we are assigning it to 0 because that is a false part. If the false part is evaluated, then again it will not evaluate the true part. So it has to go out. So that's why in 102 we have written go to 104. And in 103 we have already written the true part. The true part is if A less than B is true, then 1 has to be assigned. So that is what we have done in 103. T is equal to 1. So in 102 that is a false part, and we are saying go to 104. So it comes out of this and it can proceed with the next instructions or evaluations. Okay, so now we are going to take another construct. The construct here we have taken is A less than B or C less than D and E less than F. So in this case we are having A less than B as one condition, C less than D is another condition, and E less than F as another condition. Three conditions we are having. So for A less than B, if it is true, we may be going somewhere, and if A less than B is false, we'll be doing something else. And if C less than D is true, then we'll be going to the true part, and C less than D is false means what we need to do, we need to handle that. And E less than F is true means what we need to do, and false means what we need to do. So we have to check all the three conditions, true and false parts. And then we have or and. So first we'll go to the conditions, the three conditions. First one is A less than B, then C less than D, second one is C less than D, and third one is E less than F. So in 100th quadruple we are writing if A less than B go to 103. So this is the true part. So we are going to 103 quadruple. So what will be in 101 quadruple? It is the false part. That is A less than B is false. What we need to do? Then it is assigned as 0. So we are introducing a temporary variable T1 and we are assigning it to 0. And in 102, after giving the false part, it cannot again go into the true part, so it has to come out. So in 102 quadruple we have written go to 104. And quadruple number 103, what it is saying is T1 is equal to 1. That is a true part. If A less than B is true, then 1 has to be assigned. That is true. And after this, in 104, we are going to the next computation, next part of the computation. So here we have C less than D. So again, how we did for A less than B, again we are going to write it for C less than D. So if C less than D, go to 107. And in 105 quadruple we are writing T2 equal to 0. That means it is a false part. And in after executing the false part, we should not again go to the true part, so we'll be going to go to 108. In 106 quadruple we have written go to 108. So after completing the false part, we are going out. And in 107 it is the true part. So true part means 1 has to be assigned, so we have written T2 is equal to 1. And then after doing this, we are going into the next computation. The next condition is E less than F. So that we are writing in 108 quadruple, and there you can see if E less than F go to 111, that is a true part. And 109, what we will be writing? We will be writing the false part. The false part is T3 is equal to 0. And after doing the false part, we should not go into the true part again, so we'll come out. So in 110 we are writing go to 112, and in 111 that is the true part of E less than F, so we assign T1 is equal to 1. So now we have got all the three computations of all the three conditions. Then we are now ready to do the or and. So again we know precedence wise or and if we compare, then and has the higher precedence than or, so and part will be evaluated first and then the or part will be evaluated. So in quadruple number 112 we can see the and part getting executed. So for and part we have the temporary variables for C less than D and E less than F. For C less than D, we have the temporary variable T2, and for E less than F, we have the temporary variable T3. So we write T2 and T3, that is stored in another temporary variable t4. And then now we are left with the OR part. So in the OR part we have the a less than b, or this whole thing c less than d and e less than f. So we have t1 or t4. So that will be the 3 address code. And then this is the 3 address code for this translation. And now we'll see one more translation. Now we are going to take the construct, the while construct. So the while construct, for that one example is taken here. While a less than b, do if c less than d, then x is equal to y plus z, else x is equal to y minus z. So this is what we are having as the while construct in the source program. So how we are to convert that means, again, whenever we are using a while construct, it is flow of statements, flow of control statements. And in this if we see there is a condition always involved. If we are using a while or do while, whatever we are using, there will be a condition. If the condition is true, then again and again the statements which you have given inside the while loop will be executed again and again. And if the condition becomes false, it will come out of the while loop. So that is how it works. So we are going to use that and see how we can convert this while statement into a sequence of 3 address code. So first one, we are having a condition a less than b. So we are going to deal with that, and we are writing the code for that. If a less than b, go to L2. L2 is a label we are having. So that is we are having for our own purpose. So L2 is a label that we have given for the statement, the next statement. And if a less than b is false, then where will the control go? The control will not go inside the while loop, it will come out of the while loop. So that's why we have written in the next instruction, we have written go to L next. L next is the instruction that we'll have after the while loop, out of the while loop, not inside the while loop, because a less than b is false means it will never go into the while loop at all. And then in the L2 we are having the next condition. So when we'll have the flow of control going to L2 means a only if a less than b is true. So if a less than b is true, then it will go into the while loop, and inside the while loop we have the first statement, if c less than d. Again, that is another condition involved. So we write if c less than d. So there will be one true part and the false part. So if it is true, then what we need to do? We need to execute x is equal to y plus z. So for that we are writing go to L3. In L3 we'll write the 3 address code for x is equal to y plus z. So if the condition c less than d is true, go to L3. Okay, what will happen if the condition is false? If c less than d is false, then it will go into the else part. So for that we are writing go to L4. In L4 we will write the 3 address code for x is equal to y minus z. And in L3 what we are writing is the true part of c less than d. So here the true part is x is equal to y plus z. That is an assignment statement. So in that case what we need to do is the right hand side of the assignment we need to store it in a temporary variable, and that temporary variable you need to assign it to the left hand side of the assignment. That is how you have to do. So here we are writing t1 is equal to y plus z, and that is the right side. Right side is y plus z. So that we are assigning it to a temporary variable t1, and that temporary variable we are assigning it to the left hand side. The left hand side is x. So x is equal to t1. And then after doing this if part, the true part, then we should not go and execute the false part. So we are writing go to L1. Why we are writing go to L1? If this is done, one iteration is done, and then we have to go for the next iteration. That's why we are writing go to L1. So it goes into the starting of the while loop. Then false part. false part will be in L4. In false part, we have the assignment x is equal to y minus z. So this is an assignment statement. Assignment statement means the right hand side we need to assign it to a temporary variable, and that temporary variable we need to assign it to the left hand side. So y minus z we are assigning it to t2, and t2 we are assigning it to x. And then after doing this, we need to again go into the starting of the while loop. So for that we are writing go to L1. So L next is out of the while loop. After while loop gets executed, whatever statements comes next, that will be evaluated. So this is the 3 address code for the while construct given. Next we'll take another construct. Now this time we are going to take the for construct. So here the source code is given. Prod is assigned as 0. The variable prod is assigned to 0, and we are having a for loop. That for loop starts from 1, I is equal to 1, and then it has a condition. The condition is I less than or equal to 10, then I plus plus. That means every time it needs to be incremented. Every iteration, after every iteration, I has to be incremented. The first time I will be 1. And inside the for loop, we have prod is equal to prod plus a of I star b of I. So this is the source code given to us. We need to write the intermediate code. So if you see here, prod is equal to 0 is the first statement. That is a 3 address code by itself. So we need not change that. So we can write as such, prod is equal to 0. Then for for loop, if we take, we have I is equal to 1. That is the first assignment that is being done. So I is equal to 1, we'll write it in the next statement. Then we have to go into the evaluation of the first iteration of the for loop. So here it is an array variable. A of I is an array element. So we will be having the 4-byte addressing scheme. So we have the I multiplied by 4. So that's why we are multiplying it by 4. So I will be multiplied by 4, and it is stored in temporary variable t2, t1, and this a of I. So a of I, when we are writing, we can write it as a of t1, and that can be assigned into some temporary variables. So all these has to be stored in some temporary variables, and then it has to be used. And then similarly for b of I, again I has to be multiplied by 4. So we multiply it by 4 and store it in the temporary variable t3. And for b of I, we need to write b of t2, t3, and that b of t3 will be assigned to some temporary t4. And then we need to do the multiplication a of I multiplied by b of I. So for that we multiply t2 and t4, t2 star t4, and then that result we are assigning it to the temporary variable t5. Now what we need to do is prod has to be added with this a of I star b of I. So we are adding prod plus t5, that is t2 star t4. So that is t in t5. So prod plus t5, that is what we are assigning. Now this will be stored in some temporary variable, so that is t6, and then we are having prod is equal to t6. Yes, so then this is an assignment statement. If it is an assignment statement, what we need to do? We need to take the right hand side and store it in a temporary variable, and the temporary variable we need to store it in the left hand side. So that is what we are doing next. So we are doing prod is equal to as t7 is equal to t6. We are assigning the right hand side into a temporary variable. The right hand side is t6, and then that we are assigning it to a temporary variable t7, and then that has to be assigned to the left hand side, that is t7. Prod is equal to t7, and then one iteration is over now. So what we need to do now? we need to increment I by 1. So it is I is equal to I plus plus means it is I is equal to I plus 1. So this is an assignment statement. Whenever we have an assignment statement, what we need to do? The right hand side, we need to assign it to a temporary variable. That temporary variable we need to assign it to the left hand side. So for I is equal to I plus 1, I plus 1 is the right hand side, that we are assigning to a temporary variable. The temporary variable is T8 and that temporary variable we are assigning it to I. So that is what we have written next, and then we have incremented I. Then we need to check the condition. Yes, if the current I value is less than or equal to 10. So if now it will be 2. So here 2 is less than or equal to 10. So then it has to go inside again. So till the condition is true, it will be again and again executed. So this is the loop, for loop. So for that we are writing if I less than or equal to 10, go to L1. So L1 is the label we have given for the statement, the starting statement of the for loop, that is T1 is equal to I star 4. So this will be again and again going till the condition is true, that is I less than or equal to 10 is true. This will be again and again going. So this is the intermediate code. Hope this is clear to you. Thank you.